Alex Russell. I'm a senior staff software engineer on the Chrome team at Google, and I'm apologizing that I couldn't join you yesterday. We had a convergence for a bunch of the folks who contribute to the Blink project, which is the web engine that powers both Samsung Internet and Chrome and UC browser now, as well as many others, including Opera. And so we get together once or twice a year, and it's you know, our big engineering confab. And so I am neck deep in the web, basically. So I had to be there because one of the hats that I wear is as a quote-unquote API owner in the Blink project, but I also serve with Dan Applequist at the W3C tag. And by the way, I'm just stumbling because I can't tell you how intimidating it is to have to file a LANI. I think Dan has done this to me several times now. I don't give many talks, but this seems to be. Don't recommend this, is what I'm saying. So I'd like to start with a thesis, which is that when tapping links isn't reasonable, the web can't compete. So that's an ecosystem level question. We come to the web with the expectation as users that going from one link to the next is always going to be roughly a sane thing to do. It's not going to predate me. It's not going to take all of my data. It's not going to, you know, destroy my computer or send all of my passwords and my private data to somebody else. It's not going to create a super annoying experience. Browsers work very hard to do things like, we had a whole presentation yesterday about how we're continuing to fight the scourge of pop-unders and tab popovers and all these sorts of things. Extraordinary amounts of work goes into the project of making sure, from a browser's perspective at least, that tapping on the next link is going to be roughly reasonable. It's not going to be a bad experience. And that means that browsers have a role to play, and web developers have a role to play. So part of the reality has been that we have shifted throughout the web's history, its 25-year history. We've gone from a world that came from desktops, wired desktops, to a universe of devices that surround us that will probably never be wired. We might plug them in at night, but they probably will never send data unless we're debugging them. Most of my devices fit into this category. There's a bunch of bad news about this reality, which is that the data that, when in a wired scenario, we expect to have moderately equivalent latency, right? Latency within a relatively narrow band across the world. You might go from, you know, a 5 millisecond ping to something across the campus or across the city to maybe 100 milliseconds if you're going to Australia and back from here, to a world of mobile networks, which vary wildly. Just the latency of trying to pull a device from a low power state up to a 3G or 4G connected state can take seconds in many cases. So the variability is extraordinary. And in 2016, the situation was better than it was in 2015 when GSMA reported that 60% of users were coming to the network on 2G connections. So we've done a lot better. That's 15% in a year. And in 2016, 2G and 3G combined were 75% of the total connection base. That isn't to say that these are the heavy users. These may not show up in your stats. For many users, connecting to heavyweight services is not a reasonable thing to do. They simply may not be in your graphs as someone who's running a service because they may not be able to get to your service. It may not be reasonable for them to do that. So how are we doing? Well, GSMA reports that in 2017, 40% of mobile connections were 2G. That's good, that's better, but 2G is still then the single most prevalent network type. And 2G and 3G combined are hovering still somewhere above 70%. This is extraordinarily sobering when you consider the latency characteristics of a 2G or 3G network. The word 3G means a lot of things. And you know, I think in emerged markets, in wealthy markets, this statistic is completely this does not represent reality. We will see significantly more LTE and 4G here than we would 2G, but we still see a lot of 3G. Google's endpoints see a lot of 3G in the US, largely because in large rural areas with relatively low cell density, you end up getting kicked off to the thing that has the broadest base of potential transmission power, and that is not 4G networks. So, and it's worth noting that this situation is changing rapidly. extraordinarily rapidly, right? Reliance Jio in India has radically transformed the network situation for hundreds of millions of users in what in operator terms is overnight, with the injection of a series of very large investments last year. The set of people with access to 4G connections at a relatively reasonable price has increased by something in the tens of millions range in 1 year. So that is a sea change, but in one country. So keep an eye on this number. It's changing, but it's not changing, I think, as rapidly as most of us would like. Most of us would like to think that our users are coming to our services from the networks that we enjoy, the ones that we understand, the ones that we believe are reasonable. It turns out, though, that the ground truth is not what we believe is reasonable in all cases. So the thesis I've got is that reliable performance matters. If we believe that clicking on a link should be a reasonable thing to do, that means that it should, not always take forever to get to the thing you want on the other side. There's a variance. And if the variance is relatively low, if clicking on something gets me to the other side of it in a couple of seconds, then I'll continue to do that. But if 1 time in 10, or 1 time in 5, or 1 time in 2, it takes 100 seconds, the entire ecosystem of things that I might choose to tap on starts to feel suspect. This isn't then a reasonable thing necessarily to do. Same thing goes for all the other aspects. If it drains my battery 1 time in 5, if it eats all of my data allowance 1 time in 5, suddenly the web overall, as an ecosystem, starts to feel like it may not be a thing that you want in your life. It may not be a reasonable thing to do. The promise of the link, the reasonably average latency that is reliable, stops being reasonable. And we know that this matters to businesses. Doubleclick reported a couple of years ago that 53% of users, and this again is in wealthy markets, will abandon a site if it takes more than 3 seconds to load. So people get used to things that work well, and they bounce from things that don't. And I do like Monica's performance test about this, which is that if it takes longer for the thing to load than you'd be comfortable making eye contact with someone, it's probably too long. I tend to agree, and not just because I'm an introvert. So this is all stuff that if you've seen me give a talk before, you've probably seen me witter on about already. The situation here is one where I keep hoping to not give this talk again, and it keeps getting revived like a bad joke. So we are, however, getting new and interesting data. This is data that we pulled for the BlinkOn talk a couple of days ago. FCP is first contentful paint. This is a metric that we use inside of Chromium and in Blink to try to understand whether or not users are getting content. Personally, I don't believe that this is a good metric for determining whether or not something is good or bad. I think that time to interactive is a better metric. That is to say, if you can see it, but you can't tap it, or it doesn't do something when you tap it, how long until it does something when you tap it? That's TTI. TTI is usually sometime after FCP. So first contentful paint is a metric that we look at. And what we're seeing here is that at the, at the 50th percentile for both Windows and Android, we're OK. But at the 99th percentile for both Windows and Android, getting the first bit of developer-provided content onto the screen takes more than 15 seconds. That's 1 in, what is that, 99th percentile. So that's 1 in 100 pages that you load. Or a user, 1 in 100 users for whom every page they load. That's a lot of users. We have other data suggesting that things aren't necessarily going great. Please ignore some of that big jumping around at the front of this graph. We fixed some of our metrics. We shouldn't be looking at things where we're measuring what the background pages are doing. But EQT is expected queuing time. So that is to say, when I tap on the screen, how long does it take before that queued up event actually gets dispatched to the content on the page and then starts doing something with it? That is, for us, a metric of how often is the document that the developer made locked up almost exclusively with JavaScript that the developer also sent down the wire. This metric is regressing. at the 99th percentile. It's getting significantly worse for the population of Chrome users who report metrics. And so maybe we did a bad job. Maybe we had a bunch of bugs in Chrome. It turns out not. And it turns out that even selecting for geography and selecting for device class, we see the same thing. The web overall is getting slower. The web is now, this is a graph explaining how we are drowning in JavaScript. So mobile is really, really hard. The tools that we're bringing to it scare a lot of developers. It tends to make them sad. And there are lots of reasons to be sad. We've seen a long history now, especially in the Android ecosystem, of bad thermal design, coupled with bad chips. I have a lot to say about the 28 nanometer process, and I had originally given a talk where I talked about how bad the 28 nanometer process and the original crop of 64-bit Android SoCs were in 2016, when that experience was a couple of years old for us, and the scars were starting to come off. But I've got some bad news. I've got some very bad news, which is that the 28 nanometer process is going to be with us for a long time. Now, for those of you who, I'm not a semiconductor engineer, I couldn't do what they do. But for folks who don't pay attention to what chips do at all, in my professional lifetime, we've gone from something like 250 to 180 nanometers, and now the best chips in the world that are being produced, the SoCs coming out of Intel and TSMC and Samsung and Qualcomm, they're all being produced at the 7 nanometer process node today. So each of those process nodes is a couple of years of development. 28 nanometers is somewhere between the 22 and 32. And the 28 nanometer process was new sometime in 2013. So we started getting chips in 2013 and 2014 being built on that 28 nanometer process node. That was 5 years ago. That's a long time in technology terms. And we would like to think that all of the new devices that we are getting no longer include chips that are being built on processes that old, right? Like, people keep making fabs. That's 4x smaller. We can get a chip today. If you buy a Samsung Galaxy S9, it has a chip fabbed on a 7 nanometer process. That's incredible. It is a beautiful piece of high-end engineering. And yet, that is not what most of the world's new users are getting. Rich users are turning in their phones and getting newer, shinier, better ones with ever smaller processes. So we should think back to what Moore's law actually says. Moore's law says that for the same area of semiconductor surface, right, for the same wafer size, about every 2 years, you get almost twice as many chips, or transistors, right, on your chip. If your chip stays the same size, you get twice as many transistors, which means that you can, for the same computing power, every couple of years, if you are continuing to follow the front end of that process node revolution, you will continue to get a chip that's half the size, or sorry, a quarter the size in terms of areal density, and if you keep your costs in terms scaling with the size of the chip itself at scale, suddenly the cost to the transistor goes down, right? These things scale in other ways too. If you keep your chip die the same size, you just get more transistors, and that's more power. That's more budget to do more work, potentially. There's a whole conversation here about dark silicon and how multi-core scaling has failed us and single-core scaling has failed us, and you actually don't get all of this because thermals and batteries mean that we can't keep these things spun up. But let's just keep ourselves thinking about the peak performance now, right? If we were just able to run these chips flat out, if we could melt our pockets, the phones in our pockets all day long, what would we get? Well, it turns out that semiconductor process evolution has an economic component to it. Intel's latest fab, which is going to churn out 7 nanometer chips, just took an additional investment of about $7 billion to get there. TSMC, one of the largest contract manufacturers, is suggesting that it's going to take them $20 billion of total investment to spin up their fab for the 5 and 3 nanometer process nodes. So the next evolution down, to get a single chip produced out of that factory at the 5 and 3 nanometer process nodes, you have to spend somewhere between $7 and $20 billion. So there is a fixed cost component to this, and there is an opportunity space. I have started to think about this like an oil field. So I don't know if any of you have ever seen oil field topology, and apologies, Lanny, I'm going to sort of make some wild hand gestures here. But an oil field is usually a rock formation of hard rock. There's a cap of hard rock, a dome, if you will, over some softer rock. And at the bottom of that softer rock is water. And at the top of that soft rock is natural gas held, usually in liquid or in suspension in porous rock. And then below that is some other, the juicy stuff that oil companies try to extract. It's the petroleum. And so what happens is that's roughly a fixed size opportunity. Now, you have to spend money to go get at it. And you have to spend a lot of money. You have to go and invest a bunch to go figure out where that stuff is. You have to go do a bunch of R&D to figure out what would even be worth producing. That's very much like the semiconductor process. And then once you figure that out, you have to start drilling. You have to go start producing the physical infrastructure that will allow you to extract value out of it. And so you might hear in the news about how the price of oil going up means suddenly that people are going to start drilling more, which naturally would make you think that the price of oil will get down, which does happen. There are wells in the world, there are oil fields in the world which live at a border where if the price, because it costs constant dollar money to continue to produce this stuff, right? It's sort of like keeping a manufacturing line or a fab open. You have to invest money every week, every year to continue to run the thing. But that money is riding a depreciation curve down. You've already done the large capital investment to build the thing. It's already built. Okay, great. So the cheapest way in all possible moments to create new capacity for an oil field is to just turn on a drill and a derrick that and open up a tap that you had already drilled. You know you have to spend so much per week, but you're going to get some constant amount out of it. And if the price goes up above that, great, you can do it. This is exactly, well, roughly, how the economics for semiconductors work too. It doesn't make any sense to shut down a fab that's producing a 28 nanometer chip when a 7 nanometer chip is possible. You've already done the net capital investment. So what does that mean, right? That net capital investment is going to continue to ride its depreciation curve down, and if you are going to make money out of it, that means that you should continue to produce out of that facility over the entire life of the facility. You should continue to try to make chips for whatever market will take them over the life of the facility that will do this. So Moore's law is only one half of the picture. It tells you what's going to happen at the front end of the curve, but because of the fixed cost investments, we don't really understand as a community what this means for the back end of the curve. What happens at the value end of this? I think semiconductor engineers know this intuitively, but we don't talk about it very much. So this is data that Adi Osmani collected a couple years ago about how long it takes to evaluate a single megabyte of JavaScript with a bunch of devices. And what you can see is that an iPhone at the top, this has all been outclassed several years back, it is very, very, very quick. And as you go down that capability and price curve, suddenly you get to that Nexus 5 is sort of sitting somewhere right in the middle there, and the 5X isn't much further up. It's sort of about 1/3 of the way down. And what this means is that the cheapest devices, the Nexus 4 back in that was a 2013 device, 2014 device, it would take 4 seconds to evaluate a megabyte of JavaScript, just doing nothing. Whereas a Nexus 5 would take something like 2 seconds, and the 5X, which again was not a great part, that took about a second, just over a second, to evaluate a megabyte of JavaScript on a device that cost something like $350 new. So this is what the web has been doing in the meantime. You know how I said the web was getting slower? This is data from the HTTP archive showing that over the last year, we have gone from something like 400 kilobytes of JavaScript on the average page to something like 550 kilobytes of JavaScript on the average page. That's a huge jump. That's a massive jump, because JavaScript is the single most expensive asset in any page because it blocks the main thread. All right. All of this is interesting background to what's happening right now at the low end. This is a device that I was very excited to see was on sale at Flipkart last year. This is a Galaxy on 5. I think you can't get it now, but this was selling for something like $100, $100 US, unlocked, new. And this device, the Nexus 5X, which is a device that I love to hate, it was a terrible, terrible, terrible piece of junk. That packed a Snapdragon 808, which scored 3,500 on this Geekbench 3 benchmark. That On 2 was packing that, right? Okay, so that's the state of the $100 phone today. Well, or it was, rather. The $100 phone, well, this is actually an $85 phone. This is going to be a brand new device that you can buy right now. This is the Nokia One. This is an Android Go device. Android Go is a new version of Android, which is optimized for low memory devices. And this is a 4-core device. It has a gigabyte of RAM. It's got a 64-bit chip, like almost all of these devices. It's got a 64-bit chip, a 28-nanometer 64-bit chip, but it's running a 32-bit OS because with a gigabyte of RAM, you can't address more than that. So why bother? And you don't want to double the size of your pointers and all the rest. So this is $85 to $100 retail unlocked. So for 15% cheaper, but a year newer, what do I get? So remember, this is the Nexus 5X, piece of junk, total piece of junk, $350 new. $100 last year gets you one of these, and $85 this year gets you one of these. What we're looking at right now is a broadening of the computing base. We are collectively bringing computing to the margin, to people who believe that computing wasn't part of their life, wasn't something that was valuable to them, wasn't something that was going to be important to them. What we are collectively doing is bringing the internet and computing to people whom it can most directly affect. We have this extraordinary expansionary moment right now for the next billion users. And for many of them, they're going to be coming into this environment using whichever devices meet their economic needs. They have to be able to do that. And so as they discover computing, what's lying on the other side of it for them? Is this going to be a good experience? Is tapping on a link going to be a reasonable thing to do? I think that's a question that we should be thinking hard about. So again, this is where a new device in 2018 will sit you. That's roughly where we're at. Evaluating a megabyte of JavaScript for the marginal user today, someone on a device that costs less than $100, will take 3 seconds, more or less. So that 500K of JavaScript, that's a second and a half. You're going to lock up the main thread for a second and a half if you send 550K of JavaScript down the wire. Oh, sorry, I take it back. 550K of JavaScript, that was the HTTP archive. That's the compressed size. That's going to be more like 2 megabytes uncompressed. So consider that phone locked up for, what is that, 6 seconds? It's a tough time. It's a tough time to be a user on a budget device. But that's not the whole story. You know how I mentioned Reliance Jio is radically changing the economics of the world? They're doing it not just at the network, but also in bundled services and in hardware. So this is the Geophone. This is a device that runs a fork. It's called KaiOS. It's a fork of Firefox OS running something like Firefox 53. I think Firefox 60-something is the latest Firefox. This is not the most modern. At the same time, the hardware capabilities are something to talk about. You know how I was saying that $85 phone had 4 cores? They were clocked at 1.1 gigahertz. They are not speed demons. Again, the 28-nanometer process has terrible electron leakage. That means that as you scale them up from 1 gigahertz to 1.5, the battery drain goes, it falls off a cliff. It's really bad. It's not linear in any way, at a very low frequency rate for modern chips. A lot of that's fixed at 13, 11, and 7 nanometers, so they can scale up a lot higher. You're seeing that now in modern high-end phones. But this is another 28 nanometer special, but it's dual core. It's one of these A53, A7 designs. It's dual core. It has half a gigabyte of RAM. And the world changes dramatically between half a gigabyte and a gigabyte of RAM. Most of my day these days is spent looking at traces on Android Go devices and low-end devices that are between half a gigabyte and 2 gigabytes of RAM, and it is a really tough place for a browser to be today. Okay, so this sounds really bleak, and you might be saying, yes, yes, but Alex, I heard that average selling prices for phones are going up. I believe that. I believe that that's true. I've been saying for a while that the average selling price has been going down, and it was. It was going down for a long time. And in 2017, at the end of the year, we saw a huge cumulative set of increases in the average selling price of devices. At the same time, we know that there are now hundreds of millions of these low-end devices in our user base. We see them in our stats. We see them all the time. It could just be that average is a useless metric. I think that's actually what's happening here. What we're seeing right now is that at the high end, we are able to sell devices to rich users who understand the value of a personal computer that's attached to them at all times, that has their most personal data, and can assist them in so many fascinating ways. We're starting to see that value represented as a willingness to pay for an ever better version of that personal computer. But that's not the whole story, right? It doesn't take many $1,000 devices to turn into a wash as a mean, a statistical mean, if you add several dozen more $100 devices into it. You can support a higher average selling price and still support extraordinary volume growth at the very low end. And that's what the world is starting to look like today. The average is now a meaningless number. We are seeing huge numbers of new users coming into the world, each one of whom is as much a human as the user who can afford a $1,000 phone. And we are serving them potentially less well year on year. I really want to stop giving this talk. Please help me. So you might remember that in 2014, Shake It Off was, at least an American pop hit. And I feel like we're going to be stuck with a ghost of 2014 for the foreseeable future, because this 28 nanometer process is not leaving our life. The 3G networks may improve. Users might start getting access to unmetered data. That's, again, a marginal question. But over the next couple of years, we're in a situation where I did a little tiny calculation, and I believe that if you have a website that is being served over a relatively representative 3G connection, which is, let's say, a slow 3G connection, 400 kilobits of bandwidth, 400 millisecond round trip time, you could probably expect to get your thing to interactive, you've got about 130 kilobytes of total on-the-wire budget if it doesn't include much JavaScript. On a low-end device like that Moto G4 or this new Nokia 1, you can send 170 kilobytes if it isn't scripted. But if it includes a lot of JavaScript, you can probably only send 120, 130 kilobits. And that's if you send it over a single HTTP connection. That's if you negotiate TCP, DNS, TLS, and HTTP handshaking only once. If you add another connection to this thing, that bottom section there, that gets doubled. Most websites today make connections to more than 50 domains. The HTTP archive suggests that we connect to dozens of other servers for every single site. Now, not all of those connections are critical path. Not all of them have anything to do with TTI. They all cost, but they don't all cost the same. So what this means is that it takes an extraordinary amount of discipline today, and thoughtfulness, and care, and measurement to make sure that we can hit a 5-second window for a user on a representative device, let alone that low-end phone. And this matters because what we make matters. Today, we have the ability to define the future of the web's shape collectively. We don't do it individually. I work on a browser. I don't make websites. I can't make you make a good one or a bad one or a different one in any possible way. I can only hand you tools and beg you to use them well. But it helps to understand how we're all connected to help each of us understand our role in making that future better for everyone. So if I'm working on a browser, I kind of want to think about the web as a fixed point. If I'm making a UI and I'm making a set of features that can assist users, for instance, content blocking or pop-up blocking, it's helpful to think about the web as a system that doesn't change. I can go and I can deploy an intervention, or I can deploy a new feature that assists me with some of that content in a way that only requires me to launch new code. It doesn't require the developer to do anything. And there's a whole set of opportunities in that space. You can make a great browser thinking about the web as a static body of stuff. But products come with platforms, as long as they're programmable. The web is the outcome of one of the world's most programmable products, the web browser. And the platforms create developer choices, opportunities for developers to express in the set of capabilities that you've delivered on your platform what their future services can look like. Users, of course, choose those services. Users make decisions about what that's going to be. And users make cumulative decisions. They always have alternatives. In most cases, if there's a new popular service, there's going to be a native app version of it, and there's going to be potentially a web version of that service. Users have a choice. And those choices collectively end up defining our ecosystem. So as a browser engineer working on the platform, my downstream users are you, developers. We want to give you better opportunities to make better choices and better tools to help you understand the impacts of the choices that you are making. And as developers, you design the thing that the user might encounter when they tap that link. And so it is our collective responsibility to come up with an environment, an ecosystem, in which tapping on that next link is a reasonable thing to do. Bruce Lawson has always, said it much better than I could, which is that we should be striving to build a World Wide Web and not a wealthy Western web. And I couldn't agree with Bruce more. And it's important not to be distracted by key headline metrics that don't actually tell any sort of story, like average selling price. The number of users who are going to receive a phone for the first time this year is probably more than 100 million. And those users, by and large, are not getting iPhone 9s or whatever is going to be next on that benchmark. Those are the upsell devices. Those are the devices for rich users. Those are not the devices for the people that we can fundamentally enable with technology. So I've worked for a long time on the progressive web app pilot technology. It was the sort of next thing after web components and ES6. And Bruce said that PWAs may not solve problems that make daily usage for things better for everyone, but they fill an important gap. And he says that with a progressive web app, all the user downloads is the manifest file and the stuff that they already had. The vital point here is that everybody gets something and nobody's experience gets worse. We have to make it so that when everybody gets something, that something isn't bad. We're potentially on the very wrong side of that curve. Getting to the thing in the first place is now a contended question. It's worse than it looked a couple of years ago. But the great news is that we have the tools. They've finally arrived. You heard yesterday about how web components are transforming the set of JavaScript that you potentially have to send down the wire. You may not have to send a component system down. And tools like service workers are now arriving. Edge is about to ship this in Edge 17, which is hugely exciting, filling out the total browser support matrix. And if we constrict ourselves to mobile, we're there. That means that iOS Safari, which updates very quickly relative to the pack, once a new release is out, those users will have support for offline first experiences, as do almost all of the users that you will encounter in emerging markets. Even that Geophone has service worker support. Samsung Internet, of course, has been leading in bringing these experiences to users across all form factors. And thank you to Ada for bringing this experience to life for me. This is an S8 docked to a DeX device, which is actually a desktop docking system. This is a progressive web app running in desktop mode. And thanks to Samsung Internet's leadership, we're all now on the path to use the same compatible open technology to deliver these experiences from a single developer investment to users across operating systems and across form factors. So Edge is bringing this to the Windows Store. Microsoft is now committed to delivering progressive web apps that you might build and making them available to you where you're looking for them on Windows already. On Chrome OS, we're doing the same. We're working really hard to make sure that users developers who invest in great web experiences get credit for it using installability, making sure that the experiences that work well here are things that users can re-engage with over and over and over again without having to pay that continuous download tax. Once it's installed, these things will launch as standalone applications with access to things like copying the URL. So we have tools, they're great. And we haven't, I think it's worth acknowledging though, that as much as we've done, as much as building the service worker spec and the implementation and all of the work that Samsung and JunkySong have done to make sure that we have those tools in all of these Blink Drive browsers, we still see that the web is not winning the war for time spent on mobile. That was data from a couple of years ago. This is data from last year. The story is largely unchanged. So we have a long way to go. We should acknowledge that we have a long way to go. And I think it's worth asking the question, is what we're putting into the water, is the fact that we're currently drowning in JavaScript what's making it so that users aren't picking these experiences now that we've launched the tools that allow people to succeed? There's some good news. This is a graph of progressive web apps that have been installed 10 times or more every day. This is the number of distinct PWAs. I can't, again, unfortunately share absolute numbers, but this is growing slowly and steadily. This is from our internal metrics data for Chrome. I'm sure Samsung might have similar data, but we're excited to see this growing. And the fraction of time being spent is also starting to grow exponentially. It's taken a long time to get here, but users can pick these experiences when they're great. It's up to us to make sure that they are. And again, I'm afraid I can't share the exact numbers on the basis for this, but this is a 5x improvement in 6 months, and that has started to go exponential. So we know from developers that this works. Adi Osmani, again, did a case study with the Pinterest team who reinvested in their mobile web experience to make it a good experience for their users. And compared to their old mobile website, users are significantly more likely to spend time and attention inside of this version of their service. But what really excites me is that they compared it to native as well, and we can win. Web developers have the tools today to win, to be able to go drive engagement to services without asking for sort of a special exemption because it's the web. We can compete on our own terms. We don't have to make excuses anymore. And a story that's repeated over and over and over again, and the thing that gives me hope, is that when we do it right, our product market fit is incredible. The amount of space that it takes for a user on a low-end device, the amount of data that it takes to transfer to get into one of our experiences versus any of our competing platforms' experiences is minuscule. We have some of the best product market fit you could imagine. This is extraordinary. And this data is for Pinterest, but it is repeated over and over and over again. The same was true for Twitter. The same was true for Uber. The same was true for Lyft. Everybody who makes a really great PWA sees that the ability to get users into the front of that funnel and keep them there is hugely improved. So apologies for running slightly over time. I want to thank you for building a great lightweight website.